Okay, let's have a class, and we will do two work today. It's combined with two lab. One is related to the fungi, but I will have a special fungi lab for from the Amy Massini. The first lab do the training. She's a fungi specialist. We'll do the class before the Thanksgiving holiday. Okay, but we'll do some of the other general stuff, and this is the fact sheets. So let's talk about this fungi first, which is lab 14 and 15. So lab 14 and 15. So we want to talk about these pathogenic fungi. Pathogenic fungi. So what happened is that if you look at the fact sheets, the fungi basically is very messy at the bottom. This is called mycel. And then they will generate some of these called hyphae. And then they will generate those things called spores. These spores will be exposed or fly to the air, and some of them, let's say in this Kentucky Ohio River, this Appalachian Mountain area, you sometimes have a histoplasmomycosis. If you inhaled it, you may get a lung disease, and they are coming from the birds dropping. So this is what it looks like. Now, we don't care about these too much. From the microbiology standpoint, fungi is relatively large. So that could be more than 0.5 millimeter. And when they generate a daughter cell, usually they're using the ovoid methods to generate a daughter cell. And this is, we call it a broad-based budding. And we also talked about before, the fungi we do gram stain, we all call it gram stain blue. We don't call it a positive or negative. We say gram stain blue. So what are we going to do today? I had a very molded I think bread. I was just buy from the grocery store, and I have an orange also. So the orange start to molding, and then I pack them together, put in the room temperature for about 2.5 ounces. Looks like this. Very messy, very molded. Okay, so what are we gonna do? We can do all kinds of cool stuff. Because we have a magic stuff is called lactophenol cotton blue. And we also have is a very general tape right here. So the way to do this is very simple and straightforward. We will get a glass slides. That's what you did the whole semester already. So we get a glass slides. And then, how are we going to do the sample? We will be put a drop of lactophenol cotton blue. That's why it's very blue color. I should use this. Say, okay, lactophenol cotton blue, very blue. What is it? Then what we do? We have the tape. The tape, of course you have to wear gloves. We go ahead inside to touch the surface of the bread, and then we touch here. Okay? So using a tape, this tape will be already touching molded bread. And then we press it. So at the end, we will be ideally think this whole area will be lactophenylcotton blue, looks like a blue color. And then underneath microscope, this is the only time we're gonna use 40x. We want to do the observation. Now, what are the fungi gonna look like? You can look at your fact sheets. First page. Under eCampus, you can get a color picture. We will get Aspergillus. Aspergillus, what it looks like? Like this. Aspergillus. Leucippus. Leucippus, what it looks like this. Then Leucippus. And another one everybody knows, penicillin. What's a penicillin looks like? Oh, that's, look like that. Then lots of hyphea. Conidia, we also call it. It's a spore, but we call it a conidia. So your job is to figure out which one is this. It could be either one of that. Lots of people find the penicillin last year. Sometimes you will find Aspergillus, and sometimes you find Leucippus. It's a very interesting test. So that's the first job. Second job we want to talk about is generic E. coli coliform analysis in pond water. So this is, we want to talk about the first concept. We talk about the indicator bacteria. So there is a certain bacteria in the sample from the pond water or from the drinking water. We call it index bacteria or indicator bacteria, which will tell us whether had a fecal contamination. And based on United States EPA's regulation, our drinking water, our municipal drinking water, and you know that when you turn it on, you add, theoretically you can drink it because it's already been carbonization or maybe chlorinization or filtration, do all kinds of things to do. So US EPA's regulation is zero tolerance for E. coli and fecal coliform. Now, E. coli is also belonging to coliform. Okay? So the story is that long time ago, we think using E. coli, using coliform is a good indicator for fecal contamination. But later on, people find it's not very good. We're going to do the fecal coliform. Now, what's the difference between coliform and the fecal coliform is only the incubation time. This is 35 degrees Celsius. This is 44.5 degrees Celsius. That's the only difference. Then, most recent 30, 20 years, people think a very good indicator is generic E. coli. And generic E. coli has to be zero tolerance. Ideally, okay? So then, a company called 3M. If you're working in a microbiology area, you will know this company. This company created a very magic media. So today, you didn't see any agar. Is that right? We talk about the whole semester about the agar plates. And what you see is very magic tool. This is a paper media. Because it concentrated all the nutrients in this piece of paper. It's dehydrated paper media. It's called petrifilm. So that's why we call it a 3M petrifilm. It is a concentrated, I will say concentrated, dehydrated, solid paper media. Okay, now how are we going to do it? I will show you how to do it. Okay, you're going to get is a bottle of pound water. Okay, the bottle of pound water is right here. The front of the bench, that's pound water. That is also a pound of water. Looks beautiful. Okay, what's the job we wanted to do? We want to see is there coliform and fecal under the E. coli. So what we do? Because we're not assuming this pound of water have very huge amount of the coliform, okay? Same thing, we're going to prepare 2 dilution tube. This will be 9.9 ml. 9.9 ml. So you're going to first of all add 0.1 ml into the first one, then you add 0.1 ml into the second one. Now there's a difference. When we add onto the petrifilm, instead of we add 0.1 ml, we need to add 1.0 ml. That equals 1,000 microliter of petrifilm. This is very important. So, what's the final dilution factor of these two? That's a very simple math question. Will be 10 to the power of 2 and 10 to the power of 4. Okay? So, when you prepare the dilution using 100 microliter tips and the pipettes, when you add on to the petrifilm using 1 ml tips, unfortunately, I only have 2 pipettes. I will find one in our lab. Rion will bring another one in this later lab. So you guys do the dilution first, then take turn to add them onto the petrifilm. Okay? This petrifilm finished. We also going to incubate at a 35 degrees Celsius, usually 24-48 hours. The results will be very interesting. So what's the results going to be looks like? This well, you will see lots of dots like this. Okay, what is called? Very simple. Coliform. I believe you will find it. Now, how do we know they are generic E. coli then? You will see some of them looks like a blue, have a gas pack. So, blue colony with gas pack. This is generic E. coli. Okay, then if we combine it, this is called total coliform. That will be in your final exam. I tell you. There are 2 different types of the colony. Well, maybe only one. It depends. You see only those red dots there. That's coliform. And you will see some a gas bubble packaged blue colony. It's generic E. coli. So what is total coliform? You need to add them together. So this one we sometimes call it ECC, TCC, petrifilm. It's a very magic term. You can do it. Okay, so I wonder. Let's do that. I wonder everybody. We are just gonna go to the bench right there. I'll show you how to do. Okay. So just come here. I'll show how we're gonna do it. Let's do this mode first. Okay. This mode, I will suggest is two of you do as a pair because too bad. Very bad. Horrible looks. Okay. How do you do it? There are several ways to do. I would do an easy way for you. Lactophenol cotton blue, shake a little bit. Add one drop right in the middle. That's good. Okay, now we're gonna do, this is gonna be open a little bit. Don't block it, okay? We have a tape is there. Hold it like this. Then you go inside, touch any of the area. That's good enough. Then go to cover. That's done. Well, depends your technique. Okay. Averagely cover it underneath 40x to do the observation. This I will put it here. You guys take turn to do it. Okay, you can put this orange out. I don't need this orange, to be honest. Very bad. So only go there. Now, then you go back to do the petrifilm. The petrifilm, obviously, you need the dilution. That's I skip it. Okay, you know how to do dilution. We already talked. So what are we gonna do? If you finish the dilution, you need to make sure is using 100 microliter pipettes, which is the red one is at the top. Okay. Let's say you finish the dilution. I just do a demo. You finish the dilution. How you do? You need to add 1 ml. Okay, now, then put right on the middle of the circle and then let it be done. And I will usually using this presser to very gentle press a little bit. That's good. Eventually it will be all covered. What we are missing here is a label. So what we should do, before you do, label on the top. You name bench number, dilution factor. It's all pound of water, so everybody knows. This will do incubation. And on Tuesday next week, we want to see the coliform and generic coliform, and generic E. coli, and the total coliform. Okay? That's the work we're going to do. Everybody do as a pair for lactophenol cotton blue because it looks bad. Everybody do individually for the coliform, generic E. coli for the pound of water. So you finish your dilution, you finish your petrifilm, adding the sample onto the petrifilm.